Hello, welcome to part 73 of an exciting 12-part story on how do I deal with graphs in physics class. So this time we're looking at a position time graph, how to translate it, how to read it, and how to make it into a velocity time graph. So let's start with some key elements of this, and that is that one, the slope is the rate of change, and that tells us velocity. So the plus or minus tells us direction, and the number tells us the speed. All right, so the steeper the slope, the faster you go, and if you're going in the positive direction, you're going in the positive direction, positive slope. If you're going the negative slope, like this guy, you got a negative direction. So that's where we're going to start with our fundamental understanding. And so most important thing is we have to be able to actually figure out what is the slope, how do we calculate this. So let's go through that. So we've got two parts here. We have two separate slopes. We have two independent velocities. So I'm going to figure out what is the first velocity. And so to do that, I pick 2 points. I'm going to pick that point and this point here, that point there, to figure out what is my slope. And so I always make a nice little triangle. And so here I can find my change in time is 4 seconds. And if I look, my change in position is I went from 9 to -6. So that's a -15 meters. So if I want to do velocity, that is change in position over change in time. So for this first segment, that is a -15 meters in 4 seconds. All right, so now let's look at the second one, because we had two. So let's go green. Let's go green. It's very earth conscious. So let's pick this point, and we'll pick this point here again, and I'll make another triangle. And so here you can see that my change in time here, I went from 7 to 4, so that's only 3 seconds. And here I went from 3 to -6, so my change in position is -9 meters. So for this green section, my velocity is again equal to my change in position or my change in time, which is the slope of the line. And so I have a -9 meters, and this time it's in 3 seconds. So that's a little easier. I don't have to do an ugly fraction on that. So that's -3 meters per second. And then since I'm a numbers decimal type of guy, -15 divided by 4, Mr. Calculator says it is, go blue, what did you just do, computer? -3.75 meters per second. So those are the two slopes. So those are the two velocities. So now that I've calculated that, I can go down to my velocity time graph and I can draw those. So the very first one, which was in blue, was -3.75. So I'm just going to keep this thing color-coded, but I'm going to go a little bigger so we can see. Nope, I'm good there. A little bit bigger. Booyah. All right, so we've got -3.75. Now, you could go to scale here, but I'm just going to be this. And this is totally legit. And I'm going to be like, hey, you, I proclaim you to be -3.75 meters per second. And I want to make sure it's for the right amount of time. It goes for 4 seconds. So it should go to here. All right, so that's the first one. And then the second one is a +3. Why do I have a negative? That is so horrifically wrong. Have you ever done that in life? No, you went up 9, so this should be a positive. And that's way too big. Oh no, this is degrading. Don't make me do it again. I don't want to do it again. It's positive, so that's positive. Positive slope means you should have a positive velocity. Always check yourself before you, make choices. All right, so now you've got a +3, and so I'll just call this +3. That's fine. No one's to judge me but myself, but it's definitely positive, and so I'll say this is that, and so then this right here would be a 3 meters per second. And so you'll notice that I have this little moment where I instantaneously I go up here. So we don't draw a line in here, but we're saying, for the first 4 seconds, I was traveling at -3.75 meters. I was going in the negative direction. And then for the last 3 seconds, because this goes to 7 seconds, I was heading at 3 meters per second. So I went in the positive direction. And so this is how you would take the information that you got from your position time graph over here, and then you could translate it after calculating these slopes. You've calculated the velocities. Make sure you do it right. Don't be like me. And then you can just fill it out. And they should be flat lines. Okay? So one thing to keep in mind is that these are flat lines if you have constant velocity. Because before we only had one slope, so we only had one velocity for these two segments. So for the entire time, our velocity is not changing. It's just staying constant. We had this one instantaneous change, and then it went at a different speed in a different direction. All right, so that's one thing to remember. Is it a flat line or an angled line? So that is how you go and take a position time graph and analyze it, calculate slopes, and then once you have that done, you can draw a velocity time graph. So I hope you've had as much fun as I have, and hopefully you'll catch your mistakes just like I did. Bye-bye now.